Okay, so now we have a model. Right, so this is the model. Okay, so but then this is not the final model, right? So remember, at this model we need to remove all the metrics that's not significant. So basically, if you don't understand anything I do, just please let me know right away, please.
Excuse me, sir.
Yeah.
Is there any significance with respect to the null deviance and the residual deviance?
Sure. Okay. So I'll go. Let me just type this first. This is. Okay, so now we have a model with everything significant, right? So he was asking what's the null deviance and the residual deviance. So remember, so how do we evaluate how good is the model fit?
R squared.
R squared. So how is R squared calculated? So basically, R squared is calculated by the residual deviance divided by null deviance. So 1 minus residual deviance divided by null deviance. Yes.
Excuse me, can I ask what is the number of Fisher scoring iteration?
Where?
The last of the number of Fisher scoring iterations.
Honestly, I don't know. I have to double check. But okay, so basically, how the R square is calculated is basically a model. So again, model is model. Model deviance divided by model. So this is R squared. Okay. Basically, this value is just R squared. So it's model dot deviance divided by model dot null deviance. So everyone understanding what's going on? So I'll summarize. So basically, these are the two values here, right? Okay, so basically this one is saying, if you have nothing, how far you are from perfect. And this is after you have the model, how far you are from the perfect. Okay. And 1 minus that divided by that basically is how far you are closer to the perfect.
So residual deviance should always be lesser than null deviance.
Yes. Yeah, well, if you build a model that actually brings you worse, that can happen sometimes. Okay. So now we have a model. Then we want to predict the model, right? So we want to predict. So we want to do a prediction based on this model, right? So basically, the command is very easy. Just predict. Predict that you have to tell him what model you use to predict, right? So use the model. So now the question is, what's the data we use to predict? We don't have a testing data, right? So what we can do is we can have another testing data and put the testing data here, right? So if we pretend the training data is the testing data, so this is wrong, but I just show you in order to show you the command, okay? So that's the prediction. Why the values shows crazy values? This one should be from 0 to 1, right? So let's see the model again. This is the model. Then I do a prediction. The model output is post bug if post bug is bigger than 0. The output should be from 0 to 1. It's a probability, right? And why I do predict, all the results are crazy, are very large. Because I forgot to log the data. Yeah, so the data here is logged. See the mouse? Like here the data is logged, right? Here I didn't log the data. Okay, so this is one common mistake everyone forgot, right? So if you log the data, you always log the data. Okay? And when you log the data, make sure you pass 1. That's more like it. Okay. So in these predictions, basically, what people normally do is if it's bigger than 0.5, basically more than half of the probability is buggy, then you consider the thing as buggy. Right? Okay. So how do we calculate precision? So how do we calculate precision? So if you have this A, B, C, D, precision is basically A divided by A plus C, right?
Yes.
So basically, the one that's actually buggy and you predict it to be buggy divided by all the ones you say they are buggy. Right? Okay, so if you get this very clear, so when you calculate this, so there's no magical things to tell you, boom, this is precision, okay? So you have to calculate this. Make sense? Okay. Okay, so basically how do you know this is buggy? So basically, okay, so I'll do prediction. So I'll assign this to a variable. Let's say this is the P. So basically, how do I know this one is predicted to be buggy? Basically, P bigger than 0.5. So if I say P bigger than 0.5, see it changes to all true and false. Right? Okay. And the actual data, how do I know whether it is actual buggy? It's basically data $post far bigger than 0. This is actual buggy, right? Okay. So you want to get the ones that's both actually buggy and predicted to be buggy, right? So basically, okay, right? Make sense? Okay. So now basically you want to know how many of those are true. The true ones basically are A, right? Yeah, basically sum it up. Okay, so in 124 cases, you predict it to be buggy and data is actually buggy, right? Okay, so now you need to know A plus C. What's A plus C? A plus C is basically you predict it to be buggy. Right? Okay. So basically you sum P bigger than. Right? Okay, so 147, that's you predict it to be buggy. 124 is out of those 147, how many of those are actually buggy? Right? So your precision is basically this value divided by this value. Okay? So this is the precision. Make sense? Wrong?
I'm sorry, I'm confused a little bit. Isn't that the recall action there? Like, because you said you predicted buggy for A, and
Yeah.
then the false positives are B. And precision is 2 positives divided by 2 positives plus false positives. Isn't B false positives in this case? And C is true negative? Sorry, false negative?
No. Predict. Okay, so so throw away all those terms. So precision is basically whenever I say it's buggy, how many of those are actually buggy, right?
Right.
Yeah. So this is the total of I say is buggy,
Right.
right? This is how many of those are actually buggy.
Okay, so it's term.
Yeah.
Okay, that's what's confusing.
Yeah.
Okay, I got it.
Right. So don't remember like the position of these numbers. So like every time you draw this, really think what every number means. Okay, so this is precision, okay?
No, I understand.
Yeah.
That's why I was
Yeah.
asking you, because
Yeah.
I read the table like rotated with 90
Yeah.
degrees.
Yeah. Okay, so what's recall?
A divided by A plus B.
A plus B, right? Okay. So basically, what it means is what are the actual buggy, the number of actual buggy ones, right? So what are the number of actual buggy ones?
Why the precision is so long?
Huh?
Why the precision is so long?
So long?
Low, I mean,
Very low?
yeah, very low.
Well,
It trains on this data and then predicts this.
Yeah, but it's a
so
linear
it should
model.
be over.
yeah, it's a linear model. I think this is.
That's the problem of the model.
So linear models normally like this is actually very high. I think for linear model. Yeah, because linear model you can draw like a straight line, right? You can yeah, linear model you have to draw a straight line. Even though your data are there, but you cannot do any turns.
We can't draw a curved line.
You can, but it won't be a linear model. You can do it like a
The linear or unlinear is are going to be parameters
Yeah.
instead of the values, the future values.
yeah. So just for example, okay, so if your data look like this, so it doesn't matter how this straight line you draw, you won't be perfect, right? So if you do data look like this, either you draw this or this or this or this, whatever you draw, there will be like dots very far from your line, right? But if you can do turns, if you like can do this,
Yes, we just add some squares or
Yeah.
features.
yeah.
So why do you use linear model?
Because linear models are easier to explain.
So well, when we can use neural networks maybe.
But neural network cannot be explained. So this is like a lot of times, sure, you can use those. And also you can use random forms. Like you can use whatever, but the key thing is whether you want to later explain the model or not.
And why we need to explain?
Because you need to know, you need to know which factor actually impacts the output. This is more important than the classifier itself. In science, I guess.
And
In
can we
software.
do this with drop-on test?
The job one is sure, yeah. Yeah, but that won't be, well, that's a different thing, I think.
So we can
Yeah,
test
job
several
run test.
times?
Yeah, job run test is the same as the variable, same as variable importance. Right? So it tell you how important is the variable to the model outcome. It won't tell you how good is the variable to the model fit. And so when you talk about model outcome, it's more like still you're thinking about prediction, not the science itself. Yeah, but yeah, I think there's a lot of debate on that, but I don't think that's too much relevant on here.
For the explanations, the decision tree has a better explanation.
Decision tree.
Yeah, decision tree.
Yeah.
You know what's written.
Yeah, but decision tree. Yeah, but then, well, decision tree has decision tree's problem.
Yes.
Okay, so let's just calculate recall. Okay, so basically recall is basically this number divided by all the files that's actually buggy. Right, so the files actually buggy is basically this, right? And then so that's your recall. Basically, your recall is only less than 50%. So anyone wants to guess why this precision? So besides this is a linear model. Linear model sucks. But besides that, why do you think the precision and recall, especially recall, is very low? Because we didn't balance the data, right? So in our data, majority of the data is not buggy, and we never balance the data. So the model will always try to say it's not buggy, it's not buggy, it's not buggy, right? So when the model says it's not buggy, you will lower the recall. Okay, so this is just something that you want to know, right? So I'm not gonna teach because that will just introduce too much. Okay. So remember, like when you're trying to predict something, when the two classes are very unbalanced, if you do not balance the data, your recall will be very low. Like your recall will suffer for sure. Okay. So this one, so this one we did a prediction, and the prediction gives us the precision and recall, right? But this is not realistic because our training data and our testing data are exactly the same, right? So instead of doing that, we need to cut the data into two pieces. One piece of data we use as training, one piece of data we use as testing. Okay? Okay, so how do we do that? I have the scripts. It's basic programming. So there's no magic formula or magic command to say, give me tenfold. No, it won't work. And there won't be a command to tell you, give me randomly, give me a piece of training data and a piece of testing data. No, it won't work. It's basically you use R to program to say, give me a random number. In the random number, give me 30%, 20%. Right? So it's like you programming any language. Right? So this is basically what I wrote in the morning. So let's say so I just copy paste this here. Okay. So basically what it does, okay? So this one tells me how many data I have. in total. Okay, so I have 1,339 data points. Okay, so let's say today I want to pick 2/3 of the data as training, 1/3 of the data as testing. Okay, then I want to know how many is that 2/3 of the data, right? So basically I multiply that with 2 divided by 3. Okay, so I know I need 892, or actually 893 data points as training and the rest as testing, right? So this is just basic programming, right? So there's nothing fancy, okay? And because I need an integer, I cannot take a double, right? So basically I do an integer, so let it round, and the 0. Okay, so this is the number of training data I need, right? And what's my testing data set?
Length minus round.
This number going to
Yeah. So you can do either way, but what I did is easier. Is basically you just use this minus this. So yeah. So whatever you take as training, the rest is basically just testing. Okay. So basically, we know we need 893 training data and 446 testing data. Okay. So basically, this is these 2 lines. Okay. Okay. Now what we need is we need to randomly pick 893 data from our vector. Basically, consider as an array. So in any regular programming language, you have an array. The array has 1,339 data points in your array, and you want to randomly pick 893 of all of it, right? So basically, this is randomly pick a sample on the data on the size. So only you need to do is this. You need to know is this. So basically, this gives you random numbers. Okay. And you want to say all my data in this random numbers. So this is an array, right? So all my data in this random numbers, they are training data. Okay. Make sense? Everyone is following? So you want to make that random number somewhere. So this is the training index. Yeah. No? No. So for testing data, it's basically whatever that's not training that will be testing. Right? Testing equals to data. So in R and many other languages, so if you don't want that index, it's basically minus that training. So that's testing data. Okay? Everyone following what's going on? I hope this is not too hard for like programming. Okay? I hope everyone follows this. Because there's no magic formula. If there's a magic command, I will tell the magic command. There's really nothing. You have to do this programming together. Okay? So now you have training data and testing data. Now,
training data is
yes.
wrong.
The training data is wrong.
You
Why?
need to a new training data.
I need a new training data. What do you
Because the training data is like you first do a sample,
Yeah.
and then is the sample the same? You know, in the following line, you also do a sample.
Okay. Yeah. This is wrong. Yeah. So you want to do this. Yeah. So you want to do a training index
Yes.
instead of a. Thank you. Yeah. Yeah. This time should be good. Okay, so now we have training data. Let me double check. Okay. Okay, now we're good. Okay, so now we have the training data and the testing data, and basically we just build everything that we did with the training data, and then we test on the testing data, right? Am I right?
Yes, sir.
Okay. So I'll just copy the. So this is basically I just copy paste whatever we had before, right? So instead of getting the data from data, we get the data from training data, do correlation on the data, redundancy analysis on the data, build the model, and run through the model. Right? Okay, so now we have the model. So technically at this step, for every parameter, if it's lower, again, p value lower than bigger than 0.05, remove it. So I won't do this, it's just too much typing. Okay, so now I have to do a prediction. Okay, so now we predict on the testing data, right? We do p equals to model. Then we ask to get the testing data. What do I miss?
Log.
Yes, to log. Okay, so now let's calculate precision. So P bigger. Testing data. Two. Okay, so this is the precision. Okay. So basically 40 divided by 40. Okay, so this is the precision. The recall is basically basically this one. So this is recall. Okay, so recall is basically 40 divided by 71. Okay. Everyone follows me?
So, sir,
Yes.
final exam. So basically, we have to use the same kind of command inflow, and we should analyze the data actually, right?
Yes.
So how many questions will be there in the final?
3 or 4.
We have to analyze 3 to 4 data.
No, not analyze 3 or 4 data. Okay, so maybe I'll just talk about final. Okay. So basically the final I won't say build the model to this. I will ask you a more like a higher level question. For example, based on this data, the files with bug and the files without bug, who has the higher complexity? So the questions are more like higher level questions. A question that a manager or someone in life will ask you. Right? Your manager won't ask you, what's your p-value of this t-test? Right? Your manager will ask you, for all your code change, is your code change on Monday buggy or your code change on Tuesday buggy? Something like that. right? Or your manager will ask you, is more complex file buggy or more less complex file buggy? Something like this. Okay. So all the questions I have will be these high-level questions. Okay. So for example, like I said, I will ask you for the files with bug and file without bug, who has a higher priority change? Okay. So what you need to do is you need to think, in order to answer this question, what are the statistical analysis or statistical tests or whatever you need to apply for? For example, in this special case, for the file that's buggy and file without buggy, who has a higher priority? What kind of techniques do you need to use? Someone? How do you answer this question? A Wilcox test, right? So you need to do a statistical test. When you compare two things, who is higher, who is lower? Remember, there's a slide that says when you compare two distributions, if you want to know who is higher and who is lower, what do you choose? If you do not need to know who is higher, who is lower, what do you need to choose? Right? If you want to know who is higher, who is lower, what you choose, is the data normal? You choose this. If the data is not normal, you choose this. Make sense? Okay, so now we want to compare the file that's buggy and file that's not buggy. What do you need to choose? You need to use a statistical test that can tell you who's higher and who's lower, right? And that comes down to a t-test and a Wilcox test. And what's the difference between t-test and Wilcox test? Yeah. So if data is normal, you use the t-test. If data is not normal, you use the Wilcox test. So here, I assume most of the case is normal. Okay. Or you can draw a plot and you can tell me, hey, this is not normal. So I use a Wilcox test. What's the p-value of my Wilcox test? So how big are the differences? What do you use? Use effect size, right? For effect size, if it's not normal, you use a cliff D. If it's normal, you use a cohens D. Right? And as soon as you know exactly what kind of technique or what kind of analysis you need to use, you either Google it, or you go to my. This is open exam, right? So only thing I prevent you guys to do is chatting. So you cannot ask other people. You cannot chat online. Okay? You can Google. You can. So this is exactly the. So you can Google whatever you want to Google. Okay? But you cannot ask people. Okay? You cannot ask people to do the same thing for you. Okay? You can Google, right? If you want to go to my script or go to my slides to say, okay, so in this problem I want to use this technique, right? So you want to know what technique you want to use, and now you decided I want to use Wilcox test, right? Then now you want to know how do I use Wilcox test? You go to my scripts. All my scripts are there, right? And see, okay, so this is so I'm not gonna ask you to remember any command. Then just do it. Okay? Because there's Google or there's anything you can use, right? You go to my scripts or you Google to say how do you do a Wilcox test in R? Google will tell you, right? Or my script exactly says will.cox.test, whatever, right? That is, and you type that command, gives you the results in R, copy paste that thing, then in order to answer my question, you write. Well, you can write in digital. You don't have to write in the paper. You write in a digital, like in a Word doc or in a text pad, and say the answer to question 1 is the following. I did this because this is the result. Based on the result, my answer is file with buggy has a more priority.
So can we get any kind of couple of assignment questions so that we can practice before the exam?
It will all be next week. Okay, so if you understand what I'm teaching you next week, then you know. Okay. Okay, but I won't. Okay, so I won't tell you exactly what I'm gonna ask. Okay, but everything. Okay, so everything will be in my scripts. right? So for every week in Moodle, I share my scripts online, right? So if you can understand every line in the scripts, what I'm doing, then you're good to go.
So basically the exam is going to be a series of questions.
Yes.
And those questions will need to resolve or be answered by trying to resolve something or produce a model on our laptops and then calculate and give you the response based on that.
Yes. Okay.
So it's not like committing code somewhere and then you do the code. You will ask us on a piece of paper to give you that. These are the answers for the question.
Yeah, but also you need to also give me your R script.
Okay.
Yeah, so basically so in the end of the exam you give me two things. So one thing is for every question, what are the scripts you wrote for the question, right? So if you didn't do if you didn't use R to do it, you use other things or you count it by hand, I don't care. You just tell me how did you calculate it, right? So if you calculate it by R, you tell me what are the commands you run by R to calculate it. And on that paper, basically you say to answer question 1, this is my answer. I get this answer by using this analysis, and this analysis gave me this result. Based on these results, I answer this question in this way.
So, and we submit this to you by email, or how do we give you the response like at the end of the exam?
Yes,
If we do everything like-
probably by email, or there will be like a submission box by the end of the exam.
Okay.
Okay, so I'll make the submission box a Moodle by the end of the exam, and you just upload that thing on your submission box.
Exam is on the week after next week.
Yes. That's why. So every class I say try to make sure you know my scripts. So run my scripts line by line, right? So as long as you understand what I'm doing in my scripts, you're okay. Okay. So I'm not gonna ask anything that's out of my scripts. Okay. So the goal of this is when you have you want to answer a real question that's asked. So if you're data science, right? Or you do any analytics later, you want to use these techniques to answer real life questions. You know what techniques you choose, and you know how to Google it to run that technique in R and get the answer to help you answer the question. Make sense? Okay. So I was hoping I can teach tenfold. I don't think I have time. Okay, so I'll share my scripts. Okay, I won't ask you to do tenfold in my exam. Okay, so basically, the tenfold is basically instead of doing take one sample, I take 10 samples, and then rotate the 10 samples. So it's basically just normal programming. And so there's nothing specific to R. So all these are basically programming, right? So I get a sample, and do a loop from 1 to k. You know, this is the testing is this, training is this. Oh, I don't think I see this. Okay, so basically, it's something like this. Something like this, right? So I do a loop. So I speed from 1 to 10, so k can be 10. And then my training set is the part that you want. Sorry, the part is not in 1. The testing set is the part that you want. Right? And I do this 10 times. I loop it 10 times, right? This is really nothing about R, really. This is just if you can code in Java, this is the same, right? Okay. Okay. So, but I'll share all my scripts, and the tenfold I won't include it in my final. But this is very, very important. Okay. So better keep my script somewhere later in your life. If you want to use it, just copy paste it. Okay.
Professor, what's the meaning of the second parameter in the sample?
Okay. So because how big is your sample?
How big?
Yeah. How big is your sample? You mean this, right? This one. This is how big is your sample. So this is basically this is your data. So this is the data of row index. So basically this is your row index of your data. This is your data sample, the size of the sample. Okay? Yep.
Because there's two ways to use this. Another function is sample and one k Line 9.
Yeah. Okay, so I'll show you this one. So just show you the output, you know what's going on. So this one you will actually assign a new index to all the samples. So basically for all the data samples, you will assign to a group, so either between 1 and 10. Okay? Yeah. So then you just put the search index on this to get the data, right?
And what's the difference between the GLM and the LRM? Because they can both do the consistent regression.
Okay, so GL, so the basic one. So the basic one is actually LM. So this is the most simple one in R. So it's basically linear regression. So GLM is generalized linear regression. Okay. Generalized. So it supports a lot of transformations on data. Okay, so sometimes you can transform the data into this distribution to the other distribution. This one supports that more, right? So LRM is from this RMS package. This is LRM. It's from this package. So this package is from a famous person. So it's from that guy. So that person he wrote a more advanced. Basically, when you do regression, right? So you basically estimating the errors, right? So they have a basically he invents the whole RMS package. So that one is part of the RMS package. So RMS has the so basically RMS. Okay. So basically it has all the different predictions. Okay. And this is just the package.
As far as we're concerned,
Yeah.
will they make difference to us?
To your results, yes. So that one give you much better results. Well, not much better, but a little better, right? But that one GLM is the most common one. LRM just most basic. Like LM is too basic. No one uses it anymore. The GLM is mostly now the most simple one, right? So if you want to try something quickly, just throw it to GLM. So RMS, so anything that's in RMS is more advanced, right? And the results, I think the results is better than GLM. But I think the results better are in fractions. For example, like R squared, that can be maybe 80%, and that one maybe 81%. A little bit better than that. Also, if you use the model that's built by RMS, there's another like a lot of tool sets built by RMS. You can use other tool sets to analyze the model. Yeah, but those tool sets are very advanced. Like in this class, we never use those techniques. Yeah. So basically, like for example, I think precision recall, maybe you can just calculate by command in the RMS and also other parameters. Like a lot of things you can just command program by you don't have to program by yourself. Questions? Okay, so like I said, so next class is very important. Okay, so make sure you bring your laptop, and I will go very slow. Next class, okay. And I'll type one line. I'll wait for a minute for you to type the line. Okay, so I'll ask. So if you have questions, you can always ask me. Everyone, yes.
You mentioned about the libraries. Make sure that they are installed.
Yeah.
Can you please share them before the class?
They're all in my scripts.
Okay.
So so only library I will be using is the bio.
Okay.
So this one, okay. So this one. Can you guys read this?
Yeah.
So they want this. So you don't have to load this, okay? So this one takes a long time to load. So you don't have to load this. We're not gonna use this one. So other ones, just preload it.
Okay.
But sometimes I put a library in the middle of the here. Yeah.
Useful while.
Yeah. Okay. So make sure you load all the libraries, okay? So I'm not gonna sit here and wait for people to load their library. Okay. That's it.